G'day, my name is Peter Jakowetz. I'm a security consultant from Wellington. I work from Quantum Security. I've got a kind of background in electrical engineering. I studied down here in Canterbury. I really enjoy kind of breaking things. It's kind of what I spend my spare time doing. And my hobbies are like playing with old cars, playing with my cat, and playing with cheap electronics. So about 6 months ago, I was just searching Trade Me as I do, trying to find a CNC machine so I could do some woodwork. And I stumbled across a pancake maker. And I'd seen them a couple years ago on Kickstarter and went, that's pretty cool. And so when I saw one on Trade Me, went, I must have this. So purchased it and then decided that I've got to go and play around with it and break it. So today I'm going to have a bit of a chat about what the PancakeBot is, how it used to work, what I've done to it since, how it works or doesn't work now, and what I still plan to do in the future. Cool. So what is the PancakeBot? In 2015, a dude went and made a CNC pancake machine out of Lego and Lego robotics, and he threw it over the internet, and people went, that's pretty cool. So he then decided to throw it up on Kickstarter, and he got a couple $100,000 worth of backing towards it, and so he actually made it into like a real thing. So they were about $250 when they were new, and boiling down, it's a robot that makes custom pancakes. It's a 2-axis CNC machine, and you go and create a design in a little bit of software that they've made, shove it onto an SD card, plug the SD card into the printer, and profit. It's currently in version 2 of its hardware. I'm not entirely sure what the actual differences were between 1 and 2. I broker version 1, and it comes with this Pancake Painter software for creating designs. I decided that was kind of good enough, so I never really tried to replace that. So what is CNC, you might ask? CNC is computer numerical control. It's been around since about the 50s, and it was essentially because it was brought in around big machining and stuff. Instead of having to have people standing behind lathes and mills all day going and making the same thing over and over again, they decided to start automating that so that you could instead feed some code into a machine and it goes and reproduces the same thing many times. It's primarily used in manufacturing, but it's becoming more and more popular kind of for home and hobbyists. The most common thing, I guess, would be 3D printers. But it's used on things like laser cutters, water jet cutters, lathes, mills, 3D printers are all different types of CNC machines. So the PancakeBot works, so in the software you can go and import images, and it then goes and creates those into like a vectorised format. So rather than being rasterized and being lots of little dots, it tries and kind of makes the designs out of lines instead, and inputs that into the software. And then with all those lines, it creates G-code out of that, which is what the CNC machines understand. So this is an example of the G-code for that previous slide. So for like what is a pretty simple kind of design is like 1,700 lines of code. And it's, as you can see, it's mostly all the same. It's just giving coordinates on a XY plane. So what is G-code? It's the instruction set for CNC machines. It's pretty much just a big flat text file, RES274, and it's been around since the 50s as well, kind of since CNCing started becoming a thing. There's kind of 3 major types of prefixes for code. So there's G, which is addressed for prep commands, M for miscellaneous functions, so turning pumps on and off, motors on and off. You can query the machine for like the status of different things. And then you've also got X, Y, and Z positions, which is most of what was in that last slide. So as part of kind of playing around with this machine, I went and pumped out a bunch of code and tried to figure out all the different commands that were possible and what it uses. So just to kind of run through them quickly, the W commands define the workspace of a file. You can G21 sets things to millimeters. You can set positions to travel things too. The interesting one there is probably the motor on and off, which is M106 and M107. And in the case of the pancake maker, that goes and turns a pump on and off to go and splurt pancake mix over the hot plate. So this is an example of that G code from before being printed. So there's a few different, there's a whole bunch of different settings that you can set, and there's a whole bunch of variables as well when you're kind of printing with it. In this case, the mixture was probably a bit too thick and the pressure wasn't probably up high enough, and that's why it's doing the weird squiggly thing. But it kind of depends every time you print as to how well those things happen. When you're setting up a print as well, you can kind of set things in multiple layers so that you can get different colors in the end print. So in the software, you kind of set like 4 different colors, and it will do the darkest color first, wait like 30 or 45 seconds, print the next layer, let that heat up a bit and brown off, and keep going. And then you get something like that. So that's pretty cool. So then I actually had to start breaking it. So kind of actually about the first day I bought it, I just started ripping into it and wanting to see what was inside. So the whole thing's kind of powered by a Atmega 2560 microcontroller, which is a pretty common micro. It's used in Arduinos, in the Arduino Mega 2560, in fact. The big board on the right is the controller board, and that's got like SD card support, and it's got like a little LCD as well. There's a reasonably chunky 12-volt power supply in there. There's a couple just cheap NEMA stepper motors, an air and vacuum pump, which is the pump that I was talking about before, and then 2 micro valves. So one of those valves makes the pump suck, and one of them makes it push stuff out. I then kind of wanted to know what code was running on this, just to see if I could use the existing hardware to go and throw new code on, and found out that it was all open sourced, which was pretty cool. So they throw it all up online. The firmware is based on something called Marlin, which is used for a lot of 3D printing. It was created for like the RepRap 3D printers, except they went and modified a bunch of that, and they didn't comment it or anything, so you actually had no idea what they'd done to it. So I had to find an original version of that, do a diff between the two to try and find the differences, and then guess why they'd actually put those differences in. They also they've got a firmware upgrade process that wasn't particularly intuitive. Rather than just flashing it using like the Arduino IDE, which is probably the most common way to get stuff onto what's essentially Arduino. It was like a bin file to go and drop on there. There is a USB port that was on the device, except you could only use it to do firmware updates, and they disabled it for the printing. I flicked a message to the guy who actually designed it in the States, and he couldn't tell me why it was disabled, and he didn't know how to change it. So the pros of this original design was that it was tidy and small. It was pretty well supported. They've got a good website with a bunch of help on it. It makes custom designs easily, and it actually works. The downside, you've got to the main downside was that you've got to go and plug an SD card in, and that's no fun. I want to be able to lie in bed and set prints off, and and be able to automate things a bit more. And to be honest, it wasn't nearly complicated enough, and it actually worked. So what does it look like at the moment? It looks a little bit like that. Part of the reason for me having to do a lot of the work that I've done is because I tried to go and update the firmware pretty early on, and I kind of bricked it. I still don't entirely know why, but the USB has got no serial connection now. So what I did was I just ripped out all the original hardware. I left it with the stepper motors because I didn't really want to have to go and buy new ones. And I bought a second unit just so that when I broke this further, I had something to keep fall back on. So the current state. So as I said before, it's pretty much the original actual physical structure and the motors. I've then got an Arduino Mega 2560 with something called a ramps board on top, and that's like a really common 3D printing component. They're like a couple bucks from China. That then plugs into a little Raspberry Pi, and that's also got a webcam on it. Plugs into a wireless router, and then I have a Sonoff like wireless relay that goes and controls the hot plate so that I can turn that on and off wirelessly. So now, rather than having to touch the SD card, I can navigate to like a web UI, upload some G-code, print the pancake. I can get messaged when it prints, and then profit. So this is like the ramps board that I was talking about. There's not too much to it once I kind of figured out what the original hardware actually did by having a look at those G-code commands from before. I figured all I actually needed to do was throw some end stops in, which is the box on the top right, plug some motor drivers in the motor cables, which is the X and Y in the middle. D9 on the top left is the pump on and off, and then there's just 12 volt in on the bottom left. So it's pretty simple all in all. And then I had to go and throw some firmware on the Arduino. So I've gone and used the same Marlin firmware that was in the original, except they were using quite an old version 1, which had been around for quite a few years. So I've upgraded it to the 1.1. It's all written in C. It's pretty well abstracted, so you've only actually got to really play around with a couple of the files. There's like a config and a config advanced. And it's pretty much just a case of going through a couple thousand lines of code that's really well commented though, and just changing the handful of relevant bits. Marlin's, yeah, it's used for lots of 3D printers. It's used for some laser cutters and like home CNC machines. It's got about 150 commands in it, so it's reasonably fully featured. And there's a massive support community around it, which I kind of found beneficial and then really terrible as well. Like most open source software, you've got people who know lots about it and are really passionate on the forums and stuff, and then you've got lots of morons that try and tell you things that don't really actually help and just break things further. So then I've got a Raspberry Pi working as well like web server and to interface with it. So it's using something called OctoPi. I was going to do like my own web front end for it, and then I realized OctoPi, OctoPrint already existed, so someone's already done the hard work. And essentially all that is, yeah, it's like a web front end for it. You can upload G-code to it, and from there you can also control both X, Y, Z axis on the printer. It's got webcam support, so you can have a webcam on it and it can do like time lapses of your prints, because that's really necessary. And you can do things like send messages to Slack channels. It's got an API, so if I actually ended up throwing it on the internet, not just the LAN, I could do some more cool stuff with that as well. While I was debugging, there was just like a really lightweight bit of software called Pronterface or Printrun, and I used that a lot just for like testing that things were working as I kind of expected. So I ripped most of the hardware out of the main unit, and I had it on my desk and all plugged up, and then just using this was a lot easier than having to battle with the issues of like the web interface screwing up as well. To control the hot plate, I've got a Wi-Fi relay in there. I'd bought these to control some of the lights around our flat. And they're like super cheap from China. They're like less than $5. They can switch 10 amps, which is pretty cool, and they can be reflashed with new firmware as well. So you can use them for like the things like Open Home or whatever the Apple standard is for kind of smart devices. So then this is the mess of a desk trying to make this thing work. So in the kind of top right corner, there's just like a little Wi-Fi access point. The ramps board and the Arduino is the bottom right, followed by the Raspberry Pi, the power supply, and then a couple of those relays. It was quite good though, because there's like a whole kind of box section around the whole thing that I could like hide stuff in. And now it looks kind of tidy. So the design process kind of went, I figured out what all the original stuff did, broke it all apart, tried to figure out how I could replace that with open source components and open source stuff that already existed. Tracked back every wire loom and drew lots of diagrams. So there's a couple wiring looms that aren't just one-to-one that go through it. So it just meant sitting down there with a multimeter for a couple hours, pinning out every single cable. Ripped out all the old stuff, threw some firmware on the Arduino, and kept testing and breaking things. What did this kind of cost all up? Like the PancakeBot was a couple $100. Raspberry Pis are pretty cheap, less than $50. The Wi-Fi things maybe like $10. So all in all, like the whole thing kind of came in maybe for like $300, which is pretty cool for like a CNC robot. Thought it might be interesting just to kind of show like where I buy this stuff from. So AliExpress is where I get pretty much everything from because it's cheap as, it's pretty reliable, and it just takes, as long as you're prepared enough to wait a month, it's all good. Trade me's at least kind of 3 or 4 times the price, and electronic shops are like 5 times the price, but you can get it instantly. So things I want to do in the future with this is kind of customize the web UI a bit further. I really like the idea of doing some like cool kind of like spirographs and designs and stuff, so doing like some mathematical kind of designs. There's functionality through the G code to do temperature sensors as well, and to report that back. So that would be cool to kind of know what temperature the hot plate was up to. Do pressure sensors as well, so you know how much pressure is happening, and you can change that. And like doing like a self-filling pancake batter receptacle, so then you didn't have to keep filling it up, would be cool. So I would love to do a demonstration to you guys, but the demo gods were really bad to me, and everything kind of broke last night, which is kind of the general theme of while I was working on this. So throughout the whole time, like I just kept blowing stuff up. So I've been through kind of 2 or 3 Arduinos, a bunch of ramps boards, a whole bunch of motor drivers. I somehow killed an SD card. I didn't know that was possible. And part of the reason for that is I never quite got around to putting a fan in it. So the motor drivers kept overheating when I kept driving them. There's like lots of variables making pancakes apparently. So kind of going away from the more technology side, like actually trying to make a consistent pancake batter so that things are repeatable is really difficult. Also like the heat of doing different types of mixtures changes the pressures and the time for cooking and stuff. Like you've got to take a fair few things into account to try and do things without sitting right beside it. Like hardware's hard, reverse engineering's hard. You just keep, I think there's just an expectation that you're just going to keep breaking stuff, which just happens, and that's great, and that's the kind of fun of it. I found that a lot of the components were quite inconsistent. You could have 3 things come out of the same packet, and one of them might work, one of them might be way overspec'd, and one might be underspec'd. And I also don't really like pancakes. My girlfriend's had a whole lot of pancakes in the last couple months. So some useful applications, things I think I might use this for in the future, like putting some other things into it, like chocolate, maybe like you could print wax maybe and make like candles or something. I was searching the net just for some ideas of things that other people had done with it, and there's some dude on Geek Zone asking if you can print heat gaskets with it, which I don't think would be particularly good, but like, you know, it might work. I found a sweet video of a guy laser cutting a Vin Diesel bust out of ham and cheese. So I reckon it'd be quite fun to follow that up with like a pancake printed Vin Diesel. And then probably more on the useful side, teaching kids about CNC. I've got a couple of nieces that I'm trying to get into like electronics and hardware and stuff, so they're probably going to end up with one of my pancake makers at the end of all this. It's just it's much more fun being able to like play with something that you can then eat the outcome of, rather than having just to like play around with 3D printers and get little knickknacks to leave on your desk. And one of the reasons I actually started this as well is that I went and bought my whole love of cheap Chinese electronics. I bought a really cheap, crappy laser cutter. I got it secondhand from some dude who had already blown up the controller in it. But yeah, like the K40 lasers, they're really cheap out of China, but they are terrible. and they've got terrible software on them. But the actual like physical components in them are pretty good. Like the laser tubes are absolutely fine, and the actual housing's fine, and the power supplies are okay. So that's actually getting pretty much the same conversion as what the PancakeBot got with a ramps board and Arduino. It's really cheap to do because it's like less than $50 to do the conversion, and it's probably actually safer than the original hardware that was pretty rubbish. These images aren't very good, but this is like the original software for the laser cutter, and it's the only bit of software that you can use to drive it, and that's the English version. There's about 3 words of English on the entire page. They're just pretty pants. So that's some of the conversion that I've done already. And I've got a couple seconds, so... this is the Octoprint software. So I've got the PancakeBot out the back at the moment. And I will... Oh, no. Okay. Cool. If this works, that will be cool. Cool. See if I can turn on the hot plate. That might be not wanting to play ball. Yay! Cool, so the hot plate's on now, and sweet. So if I go fan on, that should... So I kind of blew up the y-axis this morning, so only like the x-axis goes, which is unfortunate. We'll see if this works very well. So I'm just letting the pump go. Oh, sorry. So the pump currently is like sucking up the mixture, so when I do this, it should start spilling out. And if I do that, yay. So yeah, if I had a y-axis working, this would be like a lot more impressive. I should probably turn the stop spilling stuff on there. I can send that home, maybe. Yeah, so essentially you can just like upload G code onto here. If I can go down the page further. Yeah, so you can just drag and drop G code files in here, and then push the print, and it just goes for gold. There's also like, you can just go and send it commands. So, like we can go M119, which should now tell me the status of all my end stops. Or it might have decided to stop responding, which it has. Yeah, and yeah, just the sort-off module is pretty basic. It's just a toggle on and off kind of thing. I'm planning on kind of doing a bit more on this and integrating it more with the web UI so that I don't have to go between 2 things. And if I can... Cool. So I've gone and thrown my code up on GitHub. It's not quite the latest version at the moment. But yeah, if you want to know anything, have a gaze at that. Flick me on Twitter, or feel free to pop out the back later and have a look at what I've done. It probably looks more impressive in person than it does on this. It's kind of fun. Yeah, any questions? Yep.
What would be involved in making edible Interleave chocolate, maybe?
Sorry?
Interleave pancake batter and chocolate?
Ooh. Dual extruding pancake maker. That sounds like it. That sounds like the next iteration of this, eh? That's awesome. Thanks for the idea.
Did you reflect your sauce, or did you say you can?
I did. Yeah.
So that's your front end thing.
I think it's easy at the moment.
Full jobs, so easy to do.
Yeah. There might be a picture somewhere here. But yes, all it is RS232, like 3.3 volt. I just like drilled a hole in the top and like shoved some headers through there so I could keep reflashing without having to pull the whole thing apart.
The cloud services.
It is appalling.
Did you say you're from Wellington?
Yeah.
There's an outfit in Wellington